Okay, so we're in section 1.1. We're towards the back, and we're starting question number 7. It's about the analysis of a hydrate. So both of you, regardless of junior or senior, should have done this lab where we had some Epsom salts and we heated them up in a crucible. We measured the mass before and after we heated it and tried to figure out basically how much water was stuck in the crystal. And I think that's one of the few labs that worked out really well last year, maybe in yours too. Some of them were just, the magnesium one didn't work. At least the numbers did. So Epsom salt is a hydrate of magnesium sulfate, MgSO4, and it is a hydrate, which means there is water molecules trapped inside of the crystal. The only thing that we don't know right now is N, which is how much is trapped in there, which is something we can figure out. So let's see what we've got. So before we heat it, we have 14.52 grams. After we heat it, we have 7.09 grams. This is the data we have. So it says describe what's happening on the molecular level for this process. So I don't know to what degree you want to write this. Basically, when you heat it up, the water is going to change into a gas and escape from the crystal. So maybe water vaporizes, escapes crystal. In AP format, you'll get questions where they say, describe what is happening. And that's why we do this in the notes. You want to try to use complete sentences for the AP exam, but basically what's happening, we are applying heat, the water molecules are vaporizing, converting into a gas, and they are escaping from the crystal. AP graders don't really like it when we write a book about it, so try to keep things kind of short. Find the empirical formula of the product. Excuse me, that's number 6. Find the formula of the hydrate. Okay. So we want to know about the water. So we want to know about moles of H2O up here. If we look at the difference in these two numbers up here, the difference is water. So we have 43 and we have 7. This is how much water we have. Thank you. This is how much water boiled off of this crystal. It's just the difference between the compound with the water, compound without the water. So as far as the moles of water is concerned, 7.43 grams of water grams to moles of water. So we need to get in the habit of using our AP issue numbers from the periodic table, which is why we're keeping the document for vectors so we can find them faster. Hydrogen is specifically 1.008. So for H2O, you've got rules for rounding. Now, AP is pretty good about being forgiving about where you rounded it. They can figure out what happened. If your answer is like 0.02 off because you rounded it in the middle, it's still going to be right. So they're not going to be difficult. 18.02 grams. We divide it out. Here's a calculator. (0.412) moles of H2O. The other one we're looking at is moles of MgSO4. And I'm going to specify here, this is the anhydrate, which means without water. That's this one. The leftover crystals after the water's gone. This is my anhydrate. So I'm going to start with 7.09 grams. Changing it to moles. I've already got the molar mass here. It's 120.36 grams. And it's 0.0589 moles. So let's take a second. Are you both with me? Mm-hmm. No issues? Okay. So then, when we want to figure out how much water is there, the ratio here is the ratio between water and this. So what we do is, I'll put N equals moles of water over moles of MgSO4. These numbers that we just found. So 0.412 moles divided by 0.0589 moles. That's what you get.
6.9 grams of 7.
Yeah, so your calculated answer is like this. It has to be a whole number. We're going to call it 7 because that's really pretty close. The last thing it says, write a balanced chemical equation for this process, include states. So let me erase this part. I guess I shouldn't erase it. I'm going to save this.
So the formula for the hydrate would be the MgSO4 and then 7H2O.
Exactly. And that's about what we're about to write within this chemical reaction. So you're right, that 7 goes here. So what we have is MgSO4 and then a dot and then 7H2O. This is a solid. We're going to heat it up and they're going to separate. We end up with two products. A solid MgSO4 and some gaseous water. Are we balanced? No. We need a 7 on the water. Now we're balanced. Here's something I mentioned in the lecture yesterday, and whether you heard it or not, I want to say it again. There was a question on the AP exam this last year where you had to balance an equation. And the first thing I'll say is like 8 out of my 9 students balanced the equation correctly. Great job. But the way they had to provide their answer, they really messed it up. So I was talking about this one in class as the example yesterday. And so they gave you this equation, there were blanks, and they were labeled A, B, and C. You just had to balance it. And then what had to happen? You had to come over here to the left side and write the coefficients. So A was 4, C was 2. Half of them got it wrong. Guess why? They put a 0. Because in chemistry, when we just leave it blank, that's an implied 1. And they looked at it and they saw this implied 1 and they put 0 and they got this whole question wrong because of that. So you could argue that it was the format's fault, not your own fault, but AP doesn't really argue with students. So yeah, they got it wrong. And it was unfortunate, but it was one of these things that we could have avoided easily. And that's why I'm talking about it now. We're going to learn from last year. Okay, so number 8, analysis of a compound in a sample via a chemical reaction. And this is exactly like number 2. So we'll go through this one, and then as you try number 2 again, this will be a good example to follow. All right, so we have 0.9132 grams of iron ore. Label iron ore. It's dissolved in aqueous hydrochloric acid. It dissolves completely, and in the process, all of the iron goes into solution as the Fe2 plus ion. Let's see, let's move on. A volume of exactly 28.72 milliliters of 0.05051 molar Anybody know what the Cr2O7 ion is yet? Oh yeah, keep working on it. It's a polyatomic ion. It's on your list. You can look it over. Okay. So there is a balanced equation here, and it's got a lot of stuff on it. So what's happening on the molecular level for this process? The iron ore has all the iron, and it has other stuff in it. So the amount of iron present can be found by seeing how many moles of this ion react with iron. So we're going to find moles of this. So once we find moles of this, then we're going to end up finding mass of our iron too. Good news is number 2 is probably even easier than this one. So moles of Cr2O7, 2 minus. Can I figure this out? There is I don't think it's on here anymore. So when you want to know moles, here's what we are going to have to figure out. So concentration is number of moles divided by volume. Okay, so this is the basic thing. And if you think about it, you might remember this. Molarity, this is concentration equals moles divided by volume. You might write it down. So what we're trying to do here is find moles, which is N. And so we'll write down the general formula. N equals concentration times volume. I multiply both sides by V. So this is basically what's going on. Here we have a concentration and the volume of this ion, which means we can figure out moles. So my concentration 0.05051. I'm going to write this as moles per liter, just so we can see what's going on. And then my volume, which is 28.72 milliliters. And you'll notice that these don't match up. So we should probably do a quick conversion. Thousand milliliters in a liter. Okay, so liters are going to cancel, milliliters are going to cancel, and we're going to be left with moles. Let's see. I've got 0.001451 moles. Questions on what we just did there? Good. Okay. So we can use this to find moles of iron. Let's see. So for moles of iron, what we're going to do is start with this number. And look at your balanced equation on your paper. It's not written up here. The relationship between moles of Cr2O7, 2 minus, and moles of iron 2 is the coefficients in the balanced equation. So what's my mole ratio here? Check your balanced equation. Everybody seeing it? 6 to 1. Coefficient for iron 2 is 6. Coefficient for this other one is 1. So we find that we have 0.008704 moles of iron 2. What's the question actually asking us to do?
Mass percent.
We want the mass percent of iron in the ore, which means we need to express this in terms of mass and compare it to our original sample. So our number here, 0.008704. And the molar mass of iron will come straight off the periodic table. We have 55.85. Multiply it out, and we find 0.4861 grams of this iron. So your percent by mass is going to be this number on top. So the amount that was our product, or our iron, is a reactant, divided by the mass of the entire piece of ore, which is at the top, 0.9132. It's going to label it ore. Make it a percentage, and we find 53.23% is iron. When you do number 2 and you submit it, don't put the chemical on there. Just write your number with the percentage. So what do we think? So if you need help on the one from number 2, you can look at this one. It's a little bit different. The only part of it that's really different is we had to use concentration to find moles rather than just molar mass. And then here, I did this in 2 steps, whereas if you see the example I gave you earlier, I just did it in 1. Because the question never actually asked for us to find this number. So we could have just put this on the end of it and saved a little bit of space. Okay. Here's another note about the AP format. If you have this big page full of work, and let's say your bottom line answer is here, but the right answer was actually here, they'll look up the page and find it, and they'll take your right answer. Unless you do this. If you circle it, they will not look around. So don't circle your answers. There's a chance that if you got it wrong, you did something right and the answer was up here. But if you circle it, they won't look. Crazy, huh? All right. No circles. That's it for Unit 1-1. I'm going to turn this recording off now.